Caching plays a major part in enabling today's system in being so highly scalable and available. In this caching concepts episode, part 1, we are going to cover the concepts which caching utilizes. In addition, we are going to cover some pitfalls about it and how it is being used all over the internet. So without further ado, let's begin. So, the things we are going to cover in this episode is what Sun Tzu would think and say about cache. We'll actually see that it's not so different than what he said about having wars between countries. We are also going to cover where caching is used, and we'll see that it's actually used in so many layers. We're going to cover the limitations of caching and how to overcome them. We are going to explicitly see how caching is used in HTTP headers. We are not going to cover everything because this is a concept, so we're going to show a few headers and how they are used. In addition, we're going to give you some recommendations on how to use caching and what is, for example, user caching, private and public, and how CDN is getting along with caching. So let's begin with the first concept. So the first concept is what would Sun Tzu say about caching. Now, Sun Tzu was a very known Chinese military strategist. He was a theorist and a philosopher, and he lived in the 6th century BCE. He was widely recognized for his major work on The Art of War, which is a book on military strategy. One of his most famous quotes was that the supreme art of war is to subdue the enemy without fighting. And if we would ask Sun Tzu about today's caching, I suspect that this is exactly the sentence he would say. He would say we need to subdue the enemy without fighting, and this is what caching does. Caching sends the content without relying heavily on the server, so we are not fighting. Our servers are not fighting because they are serving a simple cache, and as we'll see, sometimes it's not even them who sends the cache, it's other server, so the war doesn't even reach our own gates. Alright, so where is caching being used? Well, you see, it's actually everywhere. It's inside your CPU, it's inside your hard disk, it's in DNS, it's in browsers, it's in proxies, it's in reverse proxies, it's in major caches like Memcached and Redis, it's in your head, it's in your cells, it's everywhere. If you think about it, you have a short-term memory and a long-term memory. Now, in your short-term memory, you remember very fast. It's very fast, and you remember things for a quick time. But if you have a cache miss on your short memory, then you need to go to your long-term memory, and this is a much heavier process, and this is how caches work. So, one of the major things we need to remember about caches is that we need to be able to rebuild the cache if it does not exist. Now, why do I put it as one of the first slides? Because I don't like it when people teach you cache and they say everything is great, we have a cache for everything, our servers are very low utilized. I really like the concept of breaking things. Now, when things break, when your cache server breaks, when you invalidate your cache for whatever reason, you need to think how are you able to rebuild the cache if it does not exist. And there are techniques. For example, in other lectures we have covered consistent hashing. Now, consistent hashing means that sometimes if something breaks, then you don't need to change the whole circle, you move parts from one item to another. So when you implement a cache, think what do you do when you need to rebuild the cache. Now, another way to look at a cache is that you trade space for time. you put more space, you buy more memory, you buy more machines which serve as cache, you pay some external providers to give you cache, you take some memory from the browser, you put some more money on your CPU, on your hard drive, you buy space. You buy space in order to save time. Okay, so the main thing about cache is that we want to save time and we do it via space. Another thing to remember is that you need to pay attention to your eviction policy. Cache is not an easy thing. You don't want to serve stale content unless it's okay. So think ahead of time of your eviction policy and how not to serve stale data unless it's okay to serve stale data. Sometimes it's okay, but in many cases you can think when it's not okay to serve stale data, and you can split your website or whatever you have to multiple parts, where in some parts your stale data can be older and in other parts you cannot allow it. Now cache has been here for a very long time. So if you start reading about cache and cache headers in HTTP, which is a text-based protocol serving all the internet, you will see that you have many headers. Now this is a concept lecture again, so we are not going to get into all the headers, but what I want to tell you here is that you should decide which headers you use, and you should beware that there are some older headers which you should not use, such as Pragma no cache. There are newer headers to use that very same thing, but you should be aware that if you don't have control about the headers, then different servers on the layers, when you're saving your request, can treat different headers differently. So if you have multiple headers, both old and new, and even not you, a different server has different headers, then you want it will be very difficult to determine what will be the actual outcome, because different servers can use them differently. Now the main header the first header which we want to talk about is simply an HTTP header named cache control. When you think about cache, in many times this is the thing you think about. You think about the header cache control. Now this cache control has a few properties. A few of the properties are, as we specify, are whether it's private or public. Private means that only the current user or the currently client of the cache, the response is valid for him. So it's not for the whole internet, it's not a global CSS that we provide, and we don't mind which user is using it. It's a private cache for this private request or a user. Max age is in seconds. You say for how long I expect this cache to be relevant, and the client should handle it. Now as we said, there are older and newer headers. You should remember that almost for each header we are going to see there is a parallel header in which you can specify the same things. For example, you have also the expires header. Now in the expires header, it's overlapping the cache control max age, and it's saying the same thing, the max time that this response is valid. So the recommendation here is for you to be consistent. Choose your headers carefully. We prefer the cache control, and when you choose it, don't mix up with other headers, because you want to be consistent and you don't know how the intermediary servers are going to handle it. Another header is the vary header. Now the vary header is in addition to the cache control telling the client whether the cache we are serving it is varying according to some headers. So what do we mean? We mean that if we have a header vary accept encoding, vary : accept encoding, then we tell the client that Okay, we told you we have a cache for you. We told you it's valid for 2 days, but if you come to us with a request with a different encoding for with a different encoding, then I have a different cache for you. Okay, so you have different caches for different headers. So you can specify here any header and say that this cache is valid only for this header. Okay, now in mainly in items or in files such as CSS, the best practice for you is to think about your CSS and your static files as immutable resources. By immutable resources, we mean whenever you upload a new version of your file or CSS or whatever you have and you want to cache it, then when you think about it as immutable, you give it another version. For example, you give it another version and you hash it. And when you hash it or give it another version, remember, whenever you upload a new CSS version, you do a minor tweak, give it another version. So in this way, you have a different URL, and because you have a different URL, you are caching a different version, and you can serve those different versions to different pages or different clients, and you will have cache for all of them. And this also give you another benefit, which is comes along many times with the immutable data structure, is that you have now versioning for your CSS. Now let's see an example of a user cache. By user cache, remember we said that this cache is not relevant for all users. It's not a global CSS. It's for this private user, for example, his profile. So in this case, we are saying cache control colon private. The main thing here is private, and this private keyword, this private property of the cache control, tells the client that this cache is private for him. So if we have intermediary servers and they receive some headers, they know that they serve this response not to all clients, but only to this user. So we have the cache control. Here we didn't specify the max age, so we use another header of expires. Remember, if we are consistent, then we are fine. And we are saying that this cache is specifically per some value of the accept encoding header key. Now, what is this must revalidate property? The must revalidate property of the cache control asks impolitely, it's telling the client, please note, this cache is terribly not valid after expires. Never use it. I mean, it's very strict. So the must revalidate means after it expires, you must come to us. Of course, you cannot enforce him, but hopefully the implementer of the client will take this command seriously. So this means, okay, after I'm past the max age or the expires, in this example, you must revalidate the request. Now, you might have seen over some web pages some meta HTTP equiv. These are some cache control which comes in the HTML page. It is highly advisable not to use them, and so please avoid them and use only the cache headers. The cache headers are used by different layers of servers. This is your content. Don't mix your data with your caching policy. Your data is your data. This is the HTML you serve, and your cache policy should reside in headers. Don't think that this will put more force on your cache. Don't put more headers on both headers and HTTP equiv content, and in this way you think that your cache is stronger. I highly advise you to stick to the cache headers. Now, we said that we have multiple layers of cache and servers serving cache, but who are them? So Actually, our players are, for example, in HTTP requests coming from a browser, you might think that it's the browser cache and the end server cache, but no, it's the browser cache going to the ISP where there is some proxy cache, maybe. It's going then to the CDN cache, the Content Delivery Network cache, and then to the reverse proxy cache, which is residing inside your data center and your cluster, and from then either for more internal cache layers such as your internal application cache, your database cache, your disk cache, and your CPU cache. Okay, so we have many layers of cache, but these are the main ones: the browser, the proxy, the CDN, and the reverse proxy cache. Now, today we put some emphasis also on security. So remember that security comes with some disadvantages. So you add SSL to your content, but this means that all the intermediary servers cannot parse really the content. So it's very difficult for them to serve cache. So it's preventing the proxies from caching. So if you have a plain CSS, think whether you really need HTTPS or not, or SSL or not. If it's just a CSS or an image, then you might not need it, of course, and this will allow you to use caching. So remember, SSL in most cases prevent proxies from caching, and you want to utilize the process. Remember what Senzu said about cache. We don't want to fight this war. If we don't want to fight this war, we don't want this request to come to our server. We want it to stop in the ISP, we want it to stop in the CDN, of course, as much as we can, and with this we'll fulfill Senzu, the art of war. Okay, so cache, if we talked and we said images and CSS, but it's not only images and CSS. If you have a REST call or a message going to somewhere, then this can also be cached. If you have a user profile which you get from a REST call, you can also cache this. If you have an actor message, okay, going from one actor to another, you can also cache this. Of course, in this way, we have a little bit of a problem because we need now the application to store the cache. Usually in request response methodology, you have some maybe web server in the middle, but in actor messaging, you have like a direct one actor to another actor request without web servers in the intermediary of the microservices. So you need to think about caching, or cache about thinking, however you like it, in the way that you need to have cache not only for CSS and images, but also for REST calls. Now we mentioned CDNs. In many times the way you work with the CDN is that you create some subdomain. In this example, we created the subdomain cached cdn.mydomain.com, which means that whenever the client has a request, for example, we put all the CSS and all the images and whatever we want under the CDN. We upload it, let's say with the SFTP or whatever, we upload it to the CDN, and then we give the HTML a URL not into our servers but into different server. Senzu, the art of war, don't fight this war. We give the client a different server, not in our network, to contact when it's asking for this mostly static content. So the client is contacting a different server, cached CDN mydomain.com, because we redirect it to the CDN, and this CDN it provides the cache back to the user, and if it does not find it or it expires, then it forwards the request to us. So in this way we have directed a subdomain to go to the CDN, and we move some of the traffic to the CDN. Now this is excellent because in this way you redirect traffic. It's not even hitting your cache servers into the CDNs. And with this I think we end part 1 of this caching series. We have a lot to cover, What I would like to ask you is to please comment if you have any ideas about this. Please see the other videos, and if you want other videos or lectures about other topics such as philosophy, math, statistics, geography, geology, computer science, of course, and programming or history and physics, then please let us know the topic you are interested about, and we'll give you the concepts of this topic. And please remember that we're doing these episodes also as podcasts, so feel free to just listen to them without watching the lectures. So I'm expecting your comments. Please give me feedback. It's very important to me to know what you think, so that I know how to improve this for you. So thank you very much, and see you in the next lectures.